Let's just jump right in. Welcome to this explainer, where we're unpacking the ultimate engineering guide for building actual, real-world AI products. We're going to take you all the way from making your very first basic model calls right through to shipping fully realized, production-ready applications. And we're drawing all of this directly from the Essential 2026 AI Field Guide. It's going to be a fun ride.
So, here's our roadmap for today. First, the Holy Trinity. Second, a deep dive into the RAG stack. Third, modifying models. Fourth, the connective tissue known as MCP. Fifth, moving from vibe coding to agentic engineering. And finally, number 6, actually shipping to production. Let's get to it.
All right, Section 1. We're calling this the Holy Trinity: prompting, RAG, or fine-tuning. Let's kick things off with literally the most common dilemma every AI developer faces. You know the drill. The base model isn't doing what you want. So how do you fix it without making a massively costly mistake? Well, you've really got 3 main paths here, and surprisingly, a lot of people jump to the wrong one first. When you map out the options, you see prompting is the absolute cheapest and takes just minutes. Then there's RAG, Retrieval-Augmented Generation, which is, relatively cheap and takes maybe hours or a few days to set up. But then you have fine-tuning. Fine-tuning is expensive. It eats up compute, it eats up data, and it takes days or even weeks to pull off. So the golden rule, the huge takeaway here is this: always start with prompting. Seriously, if a well-crafted system prompt fixes your issue, boom, you're done. Move on. You only move to RAG when a lack of specific knowledge is the bottleneck. And you only pull the trigger on fine-tuning when RAG and prompting just aren't cutting it, and the gap is about how the model speaks or formats its output, not what it actually knows. I've seen it so many times. Trying to use fine-tuning to cram new factual knowledge into a model is a total trap. The model just ends up forgetting things badly.
Moving right along to Section 2. Let's do a deep dive into the RAG stack. Look, RAG is absolutely the most vital tool in your modern engineering stack when it comes to giving a model access to your own specific proprietary data. If your model needs to know about, say, your internal product docs or breaking news, this is your standard go-to pattern. Now, the architecture here basically divides the workload into 2 completely distinct phases. Phase 1 is this one-time indexing phase. You just run this whenever your documents change. Then, Phase 2 is the real-time querying phase, and that runs every single time a user actually asks a question.
Breaking that workflow down a bit, your data flows through 5 very specific steps. First up is chunking. This is where you split your PDFs or wikis into smaller bite-sized pieces, and trust me, how you slice this data affects literally everything downstream. Second is embeddings. You convert each of those text chunks into a vector, which is basically just a huge mathematical list of numbers that represents meaning. Third, you toss all those vectors into a vector database. Fourth is retrieval. So when a user asks a question, you embed their question, and the database finds the closest matching vectors. And finally, number 5, generation. You grab those retrieved chunks, stuff them right into the LLM's prompt, and boom, it could generate a highly accurate answer. But here's the catch. Standard RAG can totally break down if the user's query is super ambiguous. To fix this, you can add something called reranking. This uses a secondary, smaller cross-encoder model to rescore the top results from your vector database. It basically handpicks the absolute best matches, which massively improves your precision. Another option, or something you can even use together with reranking, is hybrid search. This combines your fancy vector search with good old-fashioned keyword search, catching exact names and weird jargon that vector math alone might just totally miss.
All right, Section 3. Modifying models. Fine-tuning vocabulary. Okay, so let's say you've totally exhausted prompting. You've tried RAG, and you know for a fact that your model needs a completely new style, a specific persona, or some highly narrow specialism. Welcome to the heavy alphabet soup of fine-tuning. We're going to start with LoRA, which stands for Low Rank Adaptation. See, doing a full fine-tune updates every single weight in the model, which is crazy expensive and risks this thing called catastrophic forgetting, literally where the model just forgets its previous skills. LoRA is the absolute go-to, parameter-efficient method to save you from that nightmare. It just slaps these small, lightweight adapter matrices right alongside the existing weights, and you only train those. So much smarter.
Next up in the vocab blitz is RLHF, or Reinforcement Learning from Human Feedback. You've probably heard of this one. It was the original massive breakthrough technique that took wild, unpredictable base models and actually made them helpful and honest. Basically, it works by training a separate reward model based on actual humans comparing different outputs, and then it uses reinforcement learning to steer the LLM toward getting higher rewards.
But you know how fast the AI field moves, right?
Today, DPO, Direct Preference Optimization, is the new standard. It's this brilliant simplification from 2023 that entirely skips that middleman reward model step. It just directly optimizes on preference pairs. This makes it so much easier and way cheaper to train compared to the older RLHF methods.
And finally, what if you need a tiny, super efficient model that still hits way above its weight class? That's where distillation comes in. This is basically training a small student model to directly mimic the outputs and capabilities of a massive, state-of-the-art teacher model. Honestly, it's exactly how all those incredibly fast, lightweight models running on our devices today are actually made.
Moving on to Section 4, the Connective Tissue MCP. So your model is trained, it's grounded, it's knowledgeable. Great. But eventually, it needs to actually talk to the outside world to do any real useful work. And that brings us to this massive open standard breakthrough that Anthropic dropped in late 2024, the Model Context Protocol, or MCP. Think about it. Previously, connecting an AI to Google Drive meant building one highly specific integration, and then Claude required a totally different one. It was a mess. With MCP, you write just one single server, and instantly any compatible AI client can securely connect to your data sources and your tools. It's not an exaggeration when people say MCP is literally the USB-C for AI. It's a total game changer.
All right, Section 5, Vibe Coding to Agentic Engineering.
Let's zoom out for a second and look at how the actual day-to-day job of software engineering is fundamentally changing because of these tools. Development right now sits on this really fascinating spectrum. On one end, you have traditional AI-assisted autocomplete, thank GitHub Copilot. Then you step up to agentic or steered development using editors like Cursor, where you're actively directing an agent to tackle massive tasks, and you're just reviewing the differences. Keep going, and you hit vibe coding. This is amazing for prototypes. You don't even read the code anymore. You literally just test the output and iterate by talking to the machine. And then at the extreme far end is fully autonomous coding, which, let's be real, is frankly a bit negligent to run today without human oversight.
And to put a pin in that, AI pioneer Andrej Karpathy recently highlighted this massive, undeniable shift. The industry is rapidly moving toward agentic engineering as the new default. We're seeing developers completely transitioning their roles. Instead of just typing out boilerplate, they're acting as architects and reviewers, orchestrating a whole team of AI agents that are actually the ones writing the lines of code.
Finally, Section 6, Shipping to Production Realities. Let's get practical.
Look, taking these fun weekend vibe coding projects and actually hardening them into robust, enterprise-grade applications, that takes serious engineering. And the harsh reality of production starts with one word: evals. You absolutely non-negotiably must have a test set to objectively measure if your model is actually good at your specific task. Without an eval suite, you are completely flying blind. You'll literally have no idea if tweaking a prompt or changing a chunking strategy made your app better or if it just broke everything.
Next up, if you want to keep your costs from exploding and keep latency down at scale, you've got to implement prompt caching. Think about it. If you're sending a massive, dense system prompt with every single user request, prompt caching saves your system from having to reprocess that giant, repetitive block of text over and over again. It simply reuses the encoded form of that shared prefix. Honestly, for efficiency at scale, it's magic.
And finally, we have to talk about the user experience. To make sure the user doesn't sit there feeling like your application just completely froze while the AI thinks, streaming is absolutely essential. Instead of waiting for the entire massive response to finish generating, streaming delivers the text to the UI token by token in real time. It keeps the user engaged and makes the whole app feel incredibly snappy.
So there it is. You now have the complete cognitive map of the modern AI engineering stack. Everything from the nuances of prompting and RAG right through to MCP, evals, and scaling for production. So the really provocative question I want to leave you with is this: where do your current projects actually sit on this spectrum? Are you just making simple model calls, or are you building shipped, agentic products? And more importantly, how are you going to apply these tools we talked about today to totally elevate your next build? Thanks for joining me on this explainer, and as always, keep building.